here. Question number 6 I think. Find HCF of 34, 102, 102 and next that is find HCF of 70, 105, 175. Here it is given three numbers. One is 70 and 105 and 175. Clear? So here in this question we have to find the HCF of 34 and 102. Clear? In the next question 3 digits. So first we will find this. You know now first step finding factorization. Here 34 and 102. 102. Clear? So now 34 the last digit is 2. So 2 divides this 34. 2 divides this 34 because the last digit is 4. Right? So now 2 how much are 3? First you can see 2 how much are 3. Or if you know the table directly you can divide. 2 how much are 34? 2 17s are 34. Correct? So if you don't know that table, what you have to do? See 2 how much are 3? First digit is here 3. Right? So 2 how much are 3? 2 1s are 2. Correct? 2 1s are 2. See 2 2s are 4. That is greater than 3. 4 is greater than 3. We cannot divide like this here. We cannot consider 2 2s are 4. 4 is greater than 3. That means it should get equal to 3 or less than 3. Clear? The number should get equal to 3 or less than 3. That last should divide completely. Means should not leave any remainder. Clear? Dividing should not leave any remainder. Should divide completely. Okay? In this method you will divide completely. See like this. 2 how much are 3? So because that all I am saying, see the last digit. If last digit even number, then 2 divides. Okay? It is odd, then you have to think whether 3 divides or 5 table divides, 7 table divides like that. But here the last digit is 4, so 2 divides. Correct? 2 divides all the even number. So 34 is even number, right? Yes. Now see 2 how much are 3? 2 1s are 2. Clear? 2 1s are 2. We cannot write 2 2s are 4 because your number is 3, that is less than 4, right? 3 is less than 4, so we cannot write 2 2s are 4. The next number we can do 2 1s are 2 is we can write, right? 2 how much are 3? Is it possible? Is there a 2 how much are 3? 3 is not there in 2 table, right? So we can write here 2 1s are 2. 2 1s are 2. How much remaining? 3. 1 is remaining, right? 2 1s are 2. Then 3 minus 2 means remaining 1. So you must write in the next step. Here you must consider the 1. So it will become 14. This number will become 14. Clear? So 2 1s are 2 and here we will get 14. It's not 5. 4 plus 1 5. Wrong one. So you will write the 1 near to 4. Clear? So now we must write. We must consider this is a 14. Okay? So 2 how much are 14? 2 7s are 14. Clear? 2 1s are 2 and you get here 14. So 2 how much are 14? 2 7s are 14. Clear? 2 7s are 14. So the next number is 17. So 17 is a prime number, right? Is it 17 divides any other table? No. Only 17 divides 17. Clear? 17 divides 17. 17 how much is 17? 17 1s are 17. Clear? 2 17s are 34 and 17 1s are 17. Now last we got 1, remainder is 1, right? So next similarly we have to divide 102. 102, the last digit is here 2, so 2 table divides. 2 how much are 10? 2 how much are 1? Is it possible? No. So next you have to consider 2 digits. So this will get to 10, correct? 2 how much are 1 is not possible. We cannot divide. So we have to write consider the next digit also. So it will become 10. So we get 2 how much are 10? 2 how much are 10? 2 5s are 10. Clear? 2 5s are 10. Now again 2 how much are 2? 2 1s are 2. 2 1s are 2. Clear? So 2 5s are 10 and 2 1s are, this also you must divide. So 2 1s are 2. The number is 51. The answer will get 51. The last digit is here 1. Is it 2 divides? No. 1 is odd number, right? So 2 does not divide odd number. So now the 51 last digit is 1. See See in 3 table, see 21 is there, right? 21. So last digit is 1, so 3 divides. Or next table that is 7, 7 also divides. So like that you think and write which table, which number will divide 51. So you can divide like this. See next if I consider 3, whether 3 divides 51 completely or not. Okay, how to check? So divide and see. 3 how much are 5? 3 how much are 5? No, 3 2s are 6. 6 is greater than 5. That we cannot write, right? So next if you write 3 1s are 3, so this is possible. See we can write this. We can write 3 1s are 3. 3 1s are 3. How much remaining in 5? 2 is remaining. If you consider 3 1s are 3. In 5, if you subtract 3, how much remaining? 2 is remaining, right? So you will consider now this is what? 21. It's not 3. This is a 21. So you know that 3 how much are 21? 3 how much are 21? 3 7s are 21. Is it correct? See, 3 1s are 3 and 2 remaining, so it will become 21. So we get 3 how much are 21? 3 7s are 21. Clear? 3 7s are 21. Now again, the next number is here 17. You know, 17 divides 17. Right? Any other table divides 17? No. Only 17 divides 17. Right? So directly you can write 17 1s are 17. So directly divides 17 1s are 17. So next we have to write, see write like this. 34 can be written as 2 into 17. Is it correct? 34 can be written as 2 into 17. Similarly 102, 102. See we can write like this. 102 is equal to, see this can be written as 2 into 3 into 17. Clear? So that means every composite number can be expressed as product of primes. Clear? So product of a prime. That means 2 is prime, even 3 also prime, and 17 also prime number, right? So every composite number can be expressed as product of prime. Clear? That means 2 into 3 into 17. 102 can be written as 2 into 3 into 17. Clear? So next we have to write the HCF of 34, 102 is equal to. So now see the common factor. The common factor is here 2. Correct? 2 into. Is there any other common factor? Yes, that is 17. No, 3 is not there in this. Next number, that is 17. So write into 17. Into 17. Clear? In the next step, you have to multiply these two numbers. Multiply 2 into 17. You know 17 2s are. If you know the table, directly we can write, right? 7 2 17s are 34. Correct? 2 7s are 14. So 1 remaining. 2 1s are 2. 2 plus 1 are 3. So therefore HCF of 34, 102 is 34. The next number, the next question is we have to find the HCF of 70, 105, 175. So here it is given three numbers. So here what we have to do? We have to find the prime factorization of each number. We find the prime factorization of 70 and 105 and 175. Clear? So we find separately. So like this. First write 17 and the next number is 105. The next number is 175. Clear? So now we have to compare the product of these three numbers. So now first write the prime factorization of 17. You know, see the last digit. Last digit is here 0. So 2 divides, right? So now write like this. 2 how much are 7. 2 how much are 7. You know, 2 does not divide 7. But you can write less than 7, means near to 7. That is 2 3s are 6. Correct? 2 3s are 6. So write 2 3s are 6. So 1 remaining in 7. Right? So that we must write in the next step. It will becomes 10. This number will becomes 10. Clear? So now 2 how much are 10. That number also you have to divide. So divide like this. 2 how much are 10. 2 5s are Clear? 2 5s are 10. See, 2 3s are 6. Clear? 2 3s are 6. In 7, 1 remaining. That you must write here. So it will become 10. It's not 1. It will become 10. So you know that 2 divides 10. 2 how much are 10? 2 5s are 10. Clear? 2 5s are 10. So now the next number is 35. So 35, see last digit is 5. Is it 2 divides? No, 2 does not divide 35. So now you have to think which number divides 35. So 3 also does not divide 35, right? Can you see 35 in 3 table? No, 3 does not divide 35. So 35 is divisible by 5 table, right? So 5 divides 35. Even 7 also divides, but we have to write the least number. Which number will divide 35? That is a 5 table. 5 divides 35. So right, 5 how much 35. You know 5 sevens are correct. 5 sevens are 35. So which table divides 7? Only 7 divides because that is a prime number, right? 7 is prime number. So now divide like this. 7 how much 7? So 7 ones are 7. Clear? 7 ones are 7. See, 2 how much is 70? 2 35s are 70. 2 35s are 70. And next here 35 is there. No? So which table divides? That is 5 and 7. But least number is 5. Isn't it? So now 5 divides 35. 5 sevens are 35. So it is 7 divides 7 ones are 7. Okay. Now, right. 70 can be written as 70 can be written as 2 into 5 into 7. Yeah? 2 into 5 into 7. Okay. Now 105. 105. So the last digit is here 5. It will be divisible by 5 table. Definitely the last digit is 5 means 5 divides. Right? 5 table divides. So now sometimes 3 also divides because in 3 table you get 15. See, 15 last digit is 5. Isn't it? So you have to think, you have to check whether 3 divides or not. So here 3 will not divide. Is it divides? Divides. Yes. See, first check whether 3 divides or not. I think 3 divides. See, 3 how much are 10? 3 3s are 9. 3 3s are 9. So one remaining, right? So it will add in the next step, we will get 15, correct? 3 3s are 9, so it will become 15. So 3 how much are 15? 3 5s are 15. Clear? 3 3s are 9 and we will get 15. 3 5s are 15. So the next number is 35. So you know 35. Which table divides? 5 table divides. So right, 5 sevens are 35. 5 sevens are 35. Clear? So 3 3s are 9. So in 10th one remaining, right? So that you must write here. So it will become 15. So 3 how much are 15? 3 5s are 15. 3 5s are 15. So now 5 how much are 35? 5 sevens are 35. The next number is here 7. 7 how much are 7? 7 ones are 7. Clear? 7 ones are 7. So next one more number is given, that is 175. 175. Clear? So now here also the last digit is 5. Maybe 5 divides or 3 divides. First we have to see whether 3 divides or not. So we check 3. 3 how much are 1? Is it 3 divides 1? No, it's not possible. So you have to consider the 2 digit, first 2 digit. Okay? So we get 17. 17, right? 3 how much are 17? You know 3 5s are 15. 3 6 are 18. So we cannot write 18. We cannot write 6. So 5. Right? 3 how much are 17? 3 5s are 15. So much remaining? 2 remaining. 17. If you remove 15, so 2 is remaining. So it will become 25. Is it 3 divides 25? No. 3 does not divide 25. So we cannot write here 3. So 3 will not divide 175 completely. Clear? Will not divide completely. Understood? So why? Because see 3 how much is 17? 3 5s are 15. 3 5s are 15 and 2 remaining, so it will become 25. So 3 how much are 25? 3 how much are 25? We will not divide, right? We will not divide 25. So we cannot write here 3. So now we can take which table? Then which table divides 175? So last digit is 5. So 5 table definitely divides, right? So we can write 5. Correct? 5 how much are 17? 5 how much is 17? 5 3s are 15. Correct? 5 3s are 15. So we cannot write 5 4s are, that is 20. 20 is greater than 17. Correct? So we cannot write 5 4s are. So next number we can write 5 3s are. 5 3s are 15. So in that 2 remaining, right? So we get 25. So this number will become 25. So 2 5 how much are 25. So this you have to divide now. So first divide these two, means 5 how much are 17. 5 3s are 15 and 2 remaining. So we get 25. So 5 how much are 25. 5 5s are 25. So 5 divides 175 completely, right? Without leaving remainder. So remainder not be, isn't it? Should not be any remainder. So now 5 3s are 15. So we get 25. 5 5s are 25. So that means 5 35s are 175. Now I can see 35. Which table divides with this 5 table? So 5 7s are 35. Next number is 7. So write 7 1s are 7. Clear? 7 1s are 7. So now see 105. 105 can be written as 105 can be written as 3 into 5 into 7. This you must write 3 into 5 into 7. Okay? Now 175. 175 can be written as 5 into 5 into 7. 5 into 5 into 7. Clear? So now we have to find the HCF of 70, 105, 175 is the HCF of 70, 105, 175 is, see the common factor. So now what we have to do? We have to compare 70, 105, 175. Clear? The product of these numbers. So see in these three which is common. So we cannot compare only two. We have to compare 3 also. Clear? So in 3 also we should get same number. Same number we should get in each. Clear? So now see here which is the common. 2 is there in this, but here 2 is not there. So this is 2 is not common. I think here 5 is common, correct? Here also 5. And this also we can see 5. So 5 is a common factor, right? So 5 into 5 into. The next number is 7. Is it correct? Yes, 7. Here also 7. 7. So 7 is a common factor of 70, 105, 175. Okay? So next step you have to multiply this product, multiply this number. So 5 into 7. 5 into 7. 5 7s are 35. So therefore the HCF of 70, 105, 175 is a 35. Clear? So this is a finding. This is the method of finding